CloudTrade's rule system, Part 3, Basic Analytical Capture. CloudTrade's rule system is based on, surprise surprise, rules. So what's a rule? A rule is the fundamental logical unit of the rule system. There's actually nothing else in our rule system except rules. Rules can be either built-in or user-defined. Built-in rules do the groundwork for analytical capture, such as checking what's at the current position or populating something in the database from the current position, say. User-defined rules are actually sequences of other rules, either built-in rules or other user-defined rules. Fundamentally, all rules are defined as either succeeding or failing. Built-in rules succeed according to what they're written to do, i.e. read a data at the current position succeeds if it can do so. User-defined rules succeed if all of the rules in their sequence succeed as well, checked one after the other in order. The next bit is really where the magic of all of this happens, which is essentially where the magic of all logical programming happens. You'll recall that a rule can change the current position as well as read data into Grammatical's database. When a rule succeeds, it effectively changes the rule's context, i.e. the current location and the database context. A rule can have more than one way of succeeding, i.e. there may be more than one rule's context in which it can leave the rule system. The fact that rules can have more than one answer means that if later on future rules fail, you can go back to previous rules and ask them to try again. And that's the very key part of the system in particular, and of logic programming in general. Some examples of rules which can have multiple answers. A rule which finds the word date in the document followed by a valid date. There could be lots of cases where there's a date followed by a valid date. Or where it finds some text beneath address and reads it all up to including telephone number. Or a rule which finds three numbers on the same line with two decimal places where the sum of the first three equals the third and reads them into particular variables. Or a rule which finds a sequence of letters and numbers which adhere to a format, such as a registration number or a postcode. Or a rule which looks for a number of possible keywords, perhaps taken from a database. So two questions about these rules. Why is this important? And when and how does Grammatical use rules with multiple answers? And how are they written? With regards to the first question, you'll recall that a user-defined rule is a list of other rules, and it'll succeed if all of those user-defined rules succeed in sequence. Before we had rules with multiple answers, if you were going along in a sequence and you hit a failure, that was it. The whole rule would fail. Now, however, you have to consider that a rule in the sequence might only fail because the previous rule left it in the context that it didn't like. So if it fails, it can go back and ask the previous rule to try again and drop it into somewhere else. So when a rule in a sequence fails, you don't just give up. You go back to the previous rules and ask them for alternatives, and then try the subsequent rules again. This is a very powerful concept in logical programming called backtracking. Assume we've written a rule to find a contact email address. That email address may or may not be present, but it always follows the words details somewhere underneath the word contact. Our user-defined rule find contact would consist of the following sequence of rules. Find the word contact, find the word details at the same vertical location but say no more than 4 lines below it, check that what follows is a valid email address and read it into the Grammatical database. Grammatical will go down and up this list looking for alternatives until eventually it either pops out at the end with an email address or runs out of available options. For example, here we start off by finding the word contact in blue. Then we look down and see there's details below, directly below contact, so that satisfies the second part. But when we try and satisfy the third part, it isn't a valid email address, so that fails. However, we now go back to rule 2. It finds the next lot of details, happens to be another answer, but again rule 3 fails. So now the whole thing on the top left has failed, but it so happens that rule 1 has another possibility, which is contact over here on the right hand side. So the rule tries again, going down rule 2, cycling through the various details till eventually we get here. And And it just so happens that there is an email address next to details, so the whole rule finally succeeds. But note how it retried and retried and retried. And if you package that rule itself into a rule which got retried by, say, you must find English email addresses, then that rule itself will be retried until the subsequent rule, the one that checks that the email address is English, succeeds. And so that's how you build up this sort of rule system. As for how you write them, we've already seen one method. If you write a rule which is based on other rules, which themselves have multiple answers, your own rule will also have multiple answers, like find contact one. You could also write the rule more than once. You could write more than one find contact rule if you like, which perhaps find the contacts in totally different ways. Maybe even finishing with just the default value. There are also built-in rules though which have multiple answers. Point me to a line in the document, for example, is a built-in rule, and that has multiple answers. Every time you ask it to retry, it finds the next line. Similarly, point me to the next word of the line does the same thing. You ask it to retry and it just moves along on to the next one. The most important multiple answer rules are the ones which take other rules as parameters. They're sort of meta rules, and I'll be going into those in the next presentation. So we end up for the final point of this one, which is how does this system of sequences of rules with multiple answers help you solve problems of analytical capture? Because I'm sure if there are any programmers in C# or Basic or Java, they might be saying, well, you could do that. But you don't have to be a programmer to write these rules. Hopefully the worked examples will have fired your imagination a bit, but essentially this rule system allows you to express your problem in terms of the things which all have to be true, which is basically a logical statement. For example, in order to read a contact email address in the document, you have to find contact, then look underneath for details, and then look along next to details for an email address. Grammatica then took it upon itself to hunt around the document to find a place where those conditions were true, and hence pull out the answer. Although we presented an approach to rules writing where you think of your problems as a sequence of steps, when you get to the next presentation, you see that you can actually do it in a more declarative way. But for now, I hope that you can see that with no programming background, just the ability to think logically, you can write down rules which hunt things down in the document wherever they happen to be, just by describing how they relate to each other, regardless of where they are on the page. Unless the location is significant, you could put that in as a condition, of a successful rule. You can make your rules dependent on anything you like. Other rules, database content, external database lookups. And you can express the whole thing almost as a sort of true statement which has to apply in the document in order for the data to be captured. Now the next presentation we'll go on to the very important thing, which is about how rules operate on other rules. I'll see you then.